Hi there, and welcome to Mr. Carlson's lab. Today I'm going to show you some different soldering techniques that might make your life just a little bit easier. And I'm going to include some soldering tips and tricks along the way. So let's get started. So you've purchased yourself a brand new soldering iron. What's the very first thing that you should do before you even turn the soldering iron on? Well, aside from putting the iron in the stand and wetting the sponge or getting your abrasive cleaner ready, you need to have some solder ready, whether it's 6337, 6040, or lead-free, whatever you're comfortable using, you need to have that ready. Do not turn on your soldering iron until you have your solder ready. The soldering iron should be set between, say 300 degrees C and 350 degrees C to start. You'll find that that's a very comfortable range just to be working in normally. For some applications, you might need to bring that a little bit higher, and we'll talk about that here in just a little bit. So the reason that you need to have some solder ready before you turn on your brand new iron is if the tip of your brand new iron remains dry, so no solder on it, you will greatly, and I mean greatly, reduce the life of that tip, and you don't want to do that. So when you turn on your iron for the first time, this iron here is well used. This is a very old iron, I think about 20 years old now. Very dependable device. Really like using it. But I'll use this as an example here. So when you first turn your iron on, you want to have solder pretty much just laying on the tip. All right? And then when it gets hot, you're going to find that it's going to start to melt right away. Coat the tip of the iron thoroughly with solder. At that point, you can put it back in your stand. You really don't have to worry about it for a little while. Now, the tips of these newer soldering irons, they have a plating material on them, and that gives the tip an extended lifetime. Way back in the day, tips used to be made out of copper, and that's why people used to file or sand them down, is because if you apply solder to a copper tip, it will erode very fast. Now, here's the thing. If you file or sand one of these tips and take the plating off, underneath is copper, and you will erode that tip. So sometimes even within hours, a nice sharp tip will turn into a little stump at the end. You definitely don't want that to happen. So do not file or sand or even use the tip of your iron for prying on things. If you work on point-to-point wiring, sometimes it might get a little bit tempting to, say, if you're trying to work on a tube socket or something like that, you want to either unwrap a wire or, press on a wire. If you scrape the tip excessively, you're going to scrape through that plating material and then the tip is done. Now, when you're using the iron in normal service, what you do is you take it, you clean the tip off like this. So get rid of the solder. You can use one of these cleaners as well, whatever you're comfortable with. Then you'll start doing your work. So you'll start doing your soldering. And then when you're done, before you put the iron back into the holder here again, you want to re-wet the tip. Make sure there's lots of solder on it. Put it back in the tip and you're good to go. This is a necessary step, and yes, there is waste product by doing this. If you do this, your soldering iron tip will last an incredibly long time. Now, here's the thing. If you want to scrimp and save on solder, you're going to end up spending money on soldering iron tips. That's just the way it is. So there always is a little bit of a waste product there. It's just the way it is. That's why you see solder chunks all over my little sponge here, and if you were to look in here, I'm sure you'd find lots in there as well. It's just necessary. So if you buy a newer iron, say it's a Weller, Hakko, or whatever it is, you'll find that they usually come with a generic tip. And again, no matter what iron it is, always make sure the minute that you turn it on the first time that you have some form of solder laying on it so that it's wetted. Now, there's a lot of fake tips on the market. So I like Hakko products. I just always have. I find that they last a very long time. This is the original element and everything, and this is about 20 years old. Of course, I've gone through tips in that time, but everything else is still all original. Very dependable device. Cord and everything is all original. Nice silicone cord. Now, the thing is if you get a fake tip, if you're a hobbyist, that's fine. They last a fair amount of time. Genuine tips last way longer, a lot more plating on them. So there are a lot of fake tips for Hakkos out there. I call them Fakos. So there's a lot of Fako tips out there. So if you're going to be using your soldering iron on a regular basis, say you're more than average use, I guess you could say, I would definitely suggest going with a genuine tip because they really do last a long time. Again, as long as you keep it wetted and you know, you're good to it. You're not using it as a pry bar or something like that. I've desoldered this component here, and if I remove the component, you have to be very careful when you remove components from double-sided circuit boards that you do not pull the plated through hole out. So if I shine a light through here, you can see how this trace ends here, and then it carries on the other side of the circuit board and goes up to the other side here. So get a pencil to point with here. So if you look right in the center of that hole, you can see how it's shiny in there. Well, that shiny area you see in there is a barrel inside this. It's carrying this trace onto the other side, and then this is just running on. That's a plated through hole. Now, whenever you're pulling out a component, you can see the kind of glaring in there, shiny. Whenever you're pulling out a component, you got to be very careful that you don't take that plated through hole out, because you'll eliminate the connection from the top side to the bottom side of the board. When you do that, then you have to go to the top side and solder both sides. That plated through hole makes putting components in a board quite a bit easier. Just because you drop them in, you can solder them on one side and you're ready to go. Now, when you're soldering something with a plated through hole, the dwell time of your soldering iron, so the dwell time is the amount of time that you keep the iron on the trace. So the dwell time has to be just a little bit longer, because the solder has to not only flow on this side, it should flow through the hole around the lead of the component. So that way you're not only just relying upon this little solder connection here, but it's soldered right through the barrel onto the other side of the board. That just makes a good solid connection, especially in rework. Now, when these boards are put together very fast, sometimes they're not soldered very well, and you can actually see almost down the plated through hole from the other side, and they're relying upon that little barrel inside there to basically carry on to the upper side of the board. Now, that's okay, but you know, the better the connection, the better, right? So that's what dwell time is, the amount of time that you keep your iron on the board. Now you'll notice that single-sided boards won't have so much area. So all of this trace and the barrel and everything pulls heat away from your iron, and that's why you need to have a little bit more dwell time. On a single-sided board, you'd basically only have this come up to this little eyelet area here. There would be no barrel, and it wouldn't carry through onto the other side of the board. So your dwell time is going to be quite a bit less, just because it pretty much ends here. Now, it's quite a fine balance when you're soldering. If you have the iron on the board too long, you'll cause these things to lift off the board, and you don't want to do that. So having your soldering iron temperature right is very important. So when I'm soldering these boards, again, my soldering iron is between 300 and 350 degrees C, and it seems to work just fine for these plated through holes. Now, for more area, let's move this out of the way here. For more area like this, what you see right here, this, of course, is going to take quite a bit more temperature in order to desolder something. Now, you can see that they've added reliefs here. So you can see how it looks like a little cross in the center. They've done that so that soldering this is not incredibly hard, because you'd have all of this copper area pulling the heat away from that joint if they didn't have those little reliefs, and that's the reason that they add those there. It also makes desoldering a lot easier as well. That's the reason that you see those reliefs, basically just for ease of soldering, to make sure it's dependable when they're going through their process. So in order to solder a component on here again, we want to clean the tip of our iron, make sure that there's nothing on it. We would come in like so, and we're just going to touch the iron here like this. And you can see how nicely that flows around there. And we have a good connection there. So if I was to solder this other one here, you can see that there's nothing in there. It'll just fill the hole at this point. Let's give you an example here. You see it'll just start to fill the hole. See that little hole? It's going down through the hole. Now, if you've pulled the plated through hole out, if you've pulled that little barrel out of the center, it won't do that. The solder will just sit on one side of the board, and it won't connect to the other side of the board. And again, in any kind of reworking, you have to be very, very careful that you don't pull on the component. You really need a decent desoldering tool. And again, we'll do a desoldering video as well here in the very near future. I'll show you how to do that effectively and safely. You pull plated through holes out in some particular applications, and it can be a very nasty and timely fix. When working on point-to-point electronics, the procedure is very similar to working on a circuit board. So what you do is you take your component, In this case, this is a tube socket. This is an octal tube socket. So, 6V6, 6L6, 6SN7, or whatever can plug into this thing. You insert the component through the hole right there. So a little tab at the bottom of the tube socket. See, we have a resistor to this pin as well. Now, contrary to popular belief, you don't need to wrap these around the tube socket. The next time this needs to be serviced, if something goes wrong, it really makes cleaning everything off a real big pain. And again, it really isn't necessary. You just poke the components through and solder them. It's absolutely fine to do that. Or if you're more comfortable, you can wrap it as well. Now, before we solder, we want to clean the tip off again. And you just pretty much come in the same way. Now, again, we're dealing with dwell time. You can kind of watch the joint. And just make sure that there's a decent amount of solder on the connection. You can see that the flux is just run down the pin here. That can be cleaned off. And as you can see, it's a nice solid connection there. Now, way back in the day, some schools taught you to wrap the leads around the socket and then just add enough solder, basically just to coat the lead in the socket. So you'd actually still see a hole here, maybe two components wrapped around it, just a touch of solder. That really isn't good practice. Fill the hole up. You want to fill that in really well. Again, solder's cheap, and you definitely don't want to have to go in there again because something's haywire because the solder didn't take. So just fill the hole up. A little bit of extra solder isn't going to hurt anything, and you definitely know that you've got a really good connection there. And then this would run off to terminal tie strip or another tube socket or something like that. That's basically how you work on point-to-point. Not much different than circuit boards. Instead of working straight down, you're kind of working from the side, that's all. In a chassis like this, you'll see that they've got little tabs on the side of the tube socket retainer ring that you can solder to. So basically, this is just chassis ground. Again, this is somewhat of a thermal relief from soldering the tube socket directly to the chassis. Now, soldering something like this chassis is not possible with, a regular iron like this. You need to really come in with the big guns, so to say. And you need to go in here and melt this puddle like this. Now, this gets extremely hot. This is a piece of number 10 wire in here. And I did a video on these a little bit earlier. It's an old Weller D550. It gets extremely hot, much, much hotter than one of those irons can get. I'll just give you an example here. So it's dead cold right now. So I'll just put this on the chassis. And hear it humming away. See how hot that is? That's causing a piece of number 10 wire to basically glow. So you can see that it's melting this puddle already. Basically, you add solder, and eventually what's going to happen is this puddle here is going to liquefy. You can see it's already starting to liquefy. See, I'm pushing the puddle around on here already. So this is what you need to do large work like this. So you need a lot of heat. Again, this is above and beyond what a normal soldering iron will do. So if you need to do any kind of chassis soldering, you want to solder, say, a tube socket to the chassis. Now what they did here at the factory, let's take that out of here. What they did at the factory is they've used the tabs on here. You can see that there's a ground that was originally connected to one of the tabs on the side of the socket. And they wanted to make sure that the actual socket was grounded to the chassis very well so there would be no issues. You can see how that these are just riveted to the chassis, and that allows corrosion to form between here, and sometimes you get a bad connection and bad things happen. You'll get static in a circuit or, basically just a bad connection. So you don't want that to happen. So what they've done is they've used this for a ground, but they've also soldered the tube socket directly to the chassis ground for a nice solid ground. Now you can get away with soldering these little tabs here. You need to turn your soldering iron up a little bit higher. This would be 380 to 400 should be fine for something like that. And this has got some oxidization on it, so if I was to solder this, I would want to add a little bit of flux. I'll use this one here. It's in the light a little bit better. So I'll add a little bit of flux to this. That's just going to help clean that off. I'll turn my iron up just a little bit here, about 380, something like that. Grab a bit of solder. Again, wipe the tip off. And I'll come in here like so. You can see that. Hopefully you can see that. And you can see that that's a nice connection right there. That would have been a nice connection if something was in there. So no problem soldering that. No problem soldering this. And as you can see, it's a pretty direct connection, and it's pretty thick. So again, 380 to 400, no problems will solder something like that. Chassis, again, you'd need to use the larger gun with that small tip on it. In order to do surface mount soldering, things get just a little bit trickier. You need a specialized tip, or at least a different tip than what was on the other iron, different than what most irons come with. You need some pretty small diameter solder, and you need a pair of tweezers that are non-magnetic. Magnetic tweezers are a real pain. And you need to be able to hold the component onto the little circuit board or whatever. This is just a test circuit board that I have for experimenting with different components. So in order to make this work, first of all, you can set your temperature down on your iron quite a bit. I'll clean the tip off here, and you can see that I've got somewhat of a hooked tip here. And that makes work quite a bit easier. It's a pretty fine tip, and I can get in here and solder each lead. So right now, I've pretty much wiped this tip off. So what I'm going to do is add just a little bit of solder right to the tip. I'll put this down here. I'll show you what I'm doing. So I'm going to add just a little bit of solder to this tip right now, right about here, just like that. Now this solder really doesn't take all that well. So now what I'm going to do is add flux to this. This is very important for any kind of surface mount work, especially rework and anything like that. Don't rely upon the flux in the solder, or you're going to have a really rough time. So just smear it around with this. So then what you do is align the component up with the pads, just like so. Try and get everything about as centered as you can. What I usually do at this point is I just touch the top, give it a bit of a push to make sure that it's right down. Now the solder that's on the tip will get wicked up because of the flux on the pad here. So what I'm going to do is just touch the pad, and you can see that it's pretty much wicking it up and pulling it onto the surface. Now I can let go of this, and that's completely soldered at that point. So now I can move this around and make the solder connections quite a bit nicer. So I'll clean this off, and I'll just come in here like so. You can see how nicely that solders now. Come in here like so, and work my way around the device. Now, if you're working on a larger circuit board, sometimes it's not this incredibly easy to get in here and do your soldering. You go and touch that last one up. And there it is. It's soldered on. So this is just a little gate that I've soldered on here. Now what I would end up doing is, again, for this board, I would use lacquer thinner in a well-ventilated area and just clean off all the flux. And I can look through this area here to make sure that there's, no connections or anything like that. So I've got the focus fixed right now because this is such a small device. I don't want this thing to wander. But at any rate, there is no connections in there. That's pretty sound. Everything is good. At any rate, if I was to shine light under here, I would look between the leads just to make sure there's no little solder balls or anything, but I can even see on camera that it's a nice clean job. And that's how you solder components on surface mount components onto a circuit board. What I'll do is I'll get another little circuit board here, and I'll say solder on a resistor. Let's take a look at an O402 component here. So you sneeze and this one disappears. See how small that is? I'm actually using an external monitor through the camera to see this. So in order to solder this is pretty much the same way that we did the other one. We add just a little bit of flux, and we use the wetted tip of the iron to solder this down. So what I'm going to do is put this on top of the pads. I already have my tip wetted here. I'm just going to press this down just to make sure that it is on those pads. It doesn't look like it is. There it is. And at this point here, again, I'll give it a bit of a press and just touch it. And now it's on there. Now, unfortunately, it's kind of hard to see because the flux is obscuring things here. So that flux on the other side will be just fine. You want to tack the one side and then tack the other. So this side is a good solder now. Now I'm going to go back to this side here and do that side. And that little O402 component is now on there. Nice little solid connection there. Now you can see how small that component is. This kind of stuff you really want a microscope for. This is a pin. All right, so you can get an idea of how big that is. Pretty small component. Again, small microscope or magnifier, and you can get away with this. As I've mentioned in some of my other videos, once you start working with surface mount components like this, if you like to build circuit boards, you'll never go back to doing through-hole ever again. It just cuts down on all the drilling. So, and it makes nice little small circuits. You can make, some pretty compact little circuits like this. So that's how you solder all these different technologies and different size components. If you're interested in learning more about electronics, vacuum tube and solid state technology alike, or you just want to view more of my videos, I have many more videos on Patreon as well. I have an ongoing electronics course there, and I've also started releasing my printed circuit board files there. So you might want to check that out. I'll have the link just below this video in the description, and I'll probably pin the link as well just below that. So if you enjoyed this video, you can let me know by giving me a big thumbs up and hang around. There'll be many more videos like this coming in the near future, touching on vacuum tube, solid state electronics, and all sorts of other tips and tricks. So until next time, take care. Bye for now.